So that about that. So last year we had Hugo Teso here, and he presented a lot of interesting, disconcerting information about our airplane security stuff. And one of the things that was also a little bit annoying is that he couldn't give us much of the details. He wasn't allowed to. So, as it happens, this year he's allowed to say a whole lot more, which is why it's really interesting to have him back. We're right on time, and I'm giving the floor over to Hugo Teso. Thank you.
Thank you. Thanks for joining me today also. As he said, I'm here again back to talk about aviation security. It's not about airplanes, it's about aviation. So airplanes and everything that goes around the airplanes. I don't know, I know you're very comfortable there sitting on the darkness and anonymous, but I may annoy you a little bit with one short question. It's important for the talk. Can you please raise your hands if you attended my previous talk of last year here at SecT? Okay, kind of half-half. Okay, great, thank you. Thank you very much. So as he mentioned, I'm here to bring what I expect a big update on my previous talk here at SecT. It's going to be about going deeper in aviation security. You have here a few links. It's important, the last one, because on this one you can find the slides. Okay, they were not ready for the badges that you have, but then you can download them. It's my personal web server. Be calm. It's not that powerful, so take it easy. And then you have also my contact data. It's important not because I want to have hundreds of followers in Twitter, but I will publish on my website most of the materials of this talk and the upcoming ones, and I will announce that on Twitter, my Twitter account, because I don't really have a syndication on the website. Okay, so let's get started. First of all, it's not who am I, but that I'm right now unemployed. I know that most of you don't give a shit about that. It's okay, it's perfect. But it's affecting a little bit this talk, okay? Like 2 weeks or 3 weeks ago, the company I was working for closed business. I'm on the street. But one important thing is that most of the, well, all the material, the hardware I had from my company for this kind of research flow away because they want it, okay? So I will tell you how this is affecting the presentation, but one big obvious consequence is that I cannot do the demos with the real hardware here, although that would be nice, but without the hardware, no demos. Okay, but I have videos of everything and nice pictures, so should be no problem, okay? Then, the why and the what. Why the fuck I am here again on the stage talking about aviation after 2 years of doing exactly the same, and then what I'm going to try to do here, okay? First is why. Okay, the why of my aviation talks, aviation security talks, has always been the same. I would like to see aviation industry to start considering or taking security seriously. Okay, that's not happened for the last 2 years, and I don't think it's going to happen in the next 20. But I will try to. I will keep trying. Okay, so today here I am on the stage because of that, because I want for that to happen. Okay, so how do I pretend to achieve that? That's the what. What I'm going to do here. I'm here to show you my latest research, findings, vulnerabilities, and attacks, and show all of you how awesome I am. No. I'm here just to show you, or to demonstrate you that getting engaged into aviation security research is not difficult, doesn't require a huge budget, and doesn't require a lot of specific knowledge, okay? Any of you can start their own aviation security research, okay? You don't really need anything else that you don't have, okay? So I'm here because of you, because I need you. Do you recall about the SCADA security, how this all started? Like 10 years ago, Black Hat, Europe, one guy talking about SCADA security. I have some findings, nobody cared. The next year, Black Hat again, 2 guys with SCADA security. People were starting to think this may be awesome. And the third year, Black Hat again, half of the presentations were about SCADA security. And at that point, SCADA industry, governments, and people start to work towards SCADA security, okay? Problem with aviation security is that it's me, just one guy, okay? Nobody cares about me. It's like, he's talking again about aviation security, forget him. Let's blame him on the media, everybody's gonna forget. As the keynote speaker said, it's easier to just lie to your customers instead of fixing the bug, okay? But if next year at SecT I apply and I send my talk proposal, and then I got the answer, hey, sorry, dude, we already have 5 talks about aviation security, so too bad. That's going to be awesome, okay? I don't want to be alone on this. So that's the reason I am here today, okay? So please, pay attention, and if you think that is awesome, okay, take a look to my website, contact me, wherever, and hey, start doing your own aviation security. It's really funny, you will see, okay? Safety is not security. That's something I will always say. I've been saying that for 2 years. I will say that the rest of my life, okay? Why? Aviation, it's always talking about security when they mean safety. Safety is a seatbelt. You're in your car, you have an accident, the seatbelt prevents you to open your head against the car. Okay, that's safety. It's trying to save your life. Accident, safety measure. So on an airplane, it's almost the same. You also have seatbelts. If the airplane crashes, the seatbelt is going to do nothing, but you feel safer, okay? Security is about protecting the airplane, the onboard systems, the people against an attack. Somebody with mean intentions that say, okay, I see this airplane, I'm going to try to hijack it with my computer from the ground and do nasty things. This is security, okay? We are going to talk about security, not safety. And wherever you see security on aviation-related documentation or whatever, just translate that. It's not security, it's safety. You will realize. You just remember this slide and you will realize that they mean safety, not security. So the agenda for today, part 1, previously on, we will do a very quick review of my previous presentation and research, and part 2, the new stuff, okay? Improvements and new attacks, new vectors, and then all the new stuff. That's the reason I asked for how many people already attended the previous talk, okay? So I can see how fast I can go over that. So 2 years ago, the first attack I showed about aviation security was divided into the 3 common phases: discovery, information gathering, and exploiting. For discovery, I talk about aviation protocol called ADSB. Then for information gathering, I moved to another protocol, aviation specific, called ACARS, and then exploiting the systems. More information on my website about that, okay? It used to be on my company's website, no longer exists, so I have to move it to my own. Discovery, we got the airplane, we got the control tower, we got the attacker, which is the Android phone, okay? So the goal of discovery is to put on a map or on a list as many of the available targets as possible, in this case, airplanes. For that, we're going to use ADSB, which is, as I said, an aviation-specific protocol whose only purpose is to map all the airplanes on the ground or flying, okay? It's just like a beacon communication. The airplane is constantly saying, I am here, I am here, I am here. It's sending lots of data, speed, position, heading, altitude, and so on, so on, so on. Security measures of this protocol, you name it, is not going to have it, okay? Has no single security measures, okay? So you either use your own antenna, $20 USB stick, and you map your airplanes on your local area by using ADSB, or you can use publicly available resources, websites or programs that are going to make the work for you, okay? Easy. You already have a map with thousands and thousands of airplanes on real time, all the information. Now, what we want is to just get a small amount of those targets. We want to keep the ones that are vulnerable to our attack, okay? Because we are not interested in the rest. For that, we're going to use another protocol, aviation-specific, called ACARS. ACARS was intended to be something like test messaging for aviation. Plain text messages, ground to air, air to ground, just to tell the pilot if something is changed from the airline, and for the pilot to tell the airline if there is something happening on the flight. Okay, with the time it evolved. And right now you can also update the flight plan of the airplane on real time while it's flying. You can update the databases of some of the onboard systems, or even update system updates. As the keynote presenter mentioned, that's feasible, that's perfectly possible. It's a feature that is, the only problem with this feature is that it costs money, so even though it can be done, companies tend to use these features as little as possible, not to waste too much money, okay? So we carefully monitor this ACARS communication. You may say, how? Easy. You remember the security features of ADSB? Exactly the same are on ACARS. So you name it, it's not going to be there. Plain text, unauthenticated, everything. In fact, it's working on a VHF frequency, so you just turn your common radio on the ACARS frequency, and you will listen the ACARS messages. Of course, they are text, so you need to decode them, but it's as easy as that, okay? There is an Android application that you can put that with a microphone in front of the radio, tune it to the ACARS, and then it's going to translate that for you. Not that difficult, okay? So, but monitoring this protocol, we see, okay, this airplane got this flight plan, this database, this whatever, and by looking at the version and formats of these flight plans and databases, you will see, you will be able to know which systems are on board each of these airplanes, because a Honeywell Flight Management System 2000 is using a different database format that Tails Aviation Flight Management System or so on, okay? So it's just sit down, relax, and start listening to ACARS communication. It can be done with your own antenna, or also there are publicly available places, okay, where you can get this information. Now we have, let's say, 10 targets that we know they're vulnerable to the vulnerabilities we have. So how do we exploit them? Easy. We get ACARS. We prepare a message of ACARS for a, let's say, flight plan update. This flight plan is going to be the exploit because it's going to have some trick inside that is going to trigger the vulnerability on the target system, for example, the flight management system, and you're going to be able to execute code on the flight management system because of the leader payload inserted into the flight plan, and then common exploitation techniques. How to send this message? Well, software-defined radio or antennas, but it's completely illegal. Well, all this is illegal, but it can be done, okay? It's going to be limited by the power of your antenna, the airplanes around you, or you can use some other methods that we will see. And game over. That's good. That was my first attack, okay? The first attack I presented against aviation. This attack had many drawbacks, many problems. One of them was complexity. This is just a small amount of the hardware that you need in order to prepare and launch an attack like this. As you can see, it's not easy. So last year, I came to SecT and I show an improvement to this attack. Okay, let's say that you're working for an airline, okay, and your boss says, okay, please send this message to this airplane that is right now flying over Stockholm. What do you think is going to happen? Is this employee going to take the laptop, the antenna, run below the airplane, trying to send the message to the pilot? Doesn't seem feasible, right? What they do instead, airlines that want to use these kind of technologies, they pay to one of those companies. There are more, but those are 3 of the biggest ones that offer services that allow them to do that. It is the so-called ground service providers. They offer many services to airlines or aviation industry users, okay? Among others, this data link communication, okay? So what they have is plenty of antennas all around the world, okay? And they allow you to use this hardware, these antennas, to send and receive messages in exchange of some money. And in order to make it easier and better and faster and selling more than the other companies, they offer a lot of commodities, like, for example, you can use a website to send the messages and write the messages and manage your communications with the airplane, an iPad application, mobile phone application, well, you name it. They thought about everything. You can even set it with a SMS. You send an SMS message to a specific number, and this message is going to be delivered to the airplane. Great, easy. But that has one small problem, that if you don't really invest enough money, those, let's say, web applications that you use to send messages may have vulnerabilities, the ones I showed last year here. And those vulnerabilities, if exploited, may allow you to get credentials, for example, for those websites that are, by the way, open, public. You don't really need a VPN to access this login website. It's publicly available. And then if you collect credentials for those, then you are able to send messages, view the activity logs, export data. You know, you're like an airliner. You can just do whatever they can do. For example, send messages, receive messages. No more antennas needed. No more hardware needed. By using these kind of vulnerabilities, what you get is you reduce the complexity a lot. Okay? And that's good, because after my company closing business, that's all I got remaining. Okay? All the other hardware just flow away, and that's all I have right now: a small laptop and my own phone. Okay? So let's see a quick demo. This is, as I said last year, a stupid vulnerability, a stupid proof of concept. The video we're going to see here already showed it last year here, okay? So let's open this demo 1 video. Okay, give me a second. Here, stop, and put it here. Okay, what we got here is on the left, one of those websites. In this case, it's the ARINC Direct, one of the servers, providers of these technologies. And on the right, the attacker black screen, you know. So what we're going to do here is just, you can see the website. We're going to start a stupid script that is going to be listening for connections. I'm going to trigger some user of ARINC. You can just go to one aviation maintenance forum, and you can paste a link like this one with the cross-site scripting in it, and trust me, they're going to click on it. Okay, so let's say that some user clicks the link with the cross-site scripting. Okay, I made this on purpose so you can see there is the page executing the script, and you can see there that we already got a connection. Okay, a new victim made a click, and let's say that they click and they put their username and password because they want to see, for example, the new whatever. So they put the username, they put the password, and they click login. Okay, now it's not going to work because it's a fake, of course. I'm not going to use real credentials, but if the user enters valid credentials, it's going to be login and it's going to keep working. But already we received some data, okay? And if we take a look to this data, that is going to be dumped on a file. Okay, you are going to see that what we got was the username, what was this one, and the password, which is another one. Okay, you do that, I don't know, a bunch of times. Okay, let me recover my mouse here. Really? Again? Okay. So if you do that a bunch of times, you will get eventually, I don't know, a few tens of credentials, so you will be able to log into these websites and do your business. Okay, you can send messages, receive messages. Somebody's going to pay for that. So if you don't use that a lot, they are not going to notice that on the bill. And you can also just get the API, the web calls, and whatever you're going to call it, and do it with your own application. You can code your own script. Okay. In fact, I recommend that because sometimes there are some client-side protections to make sure that the ACARS message is properly set up. So if you don't want to have to intercept the calls and modify again, code your own stupid script with web requests, and it's going to be easier for you. Okay. That's all. With that, we made the same attack, but we reduced the complexity by moving that to web interface. So the exploitation phase and the enumeration phase are way simpler. Okay. So now the part 2. Let's see how to engage into an aviation security. How do I find this kind of stuff? Okay. So one day, I was just browsing the internet looking for nice cat pictures when I happened to arrive to the ARINC website, and I saw this link. Request an AMI disk. And I realized at this precise moment I needed that. I didn't have it, I want it. Okay, so I click on this link. You got a formulary. They're asking for a lot of information: name, surname, address, phone, email address. I got this, I got this, I got this, I got this. So I went through all the formulary, and I realized, you're not asking for a credit card? Okay, send me two, no problem. If you're not, I mean, I have everything but the credit card. So if they're not asking, so I fill up all the form, press the send button and sit on my place waiting for the AMI disk. A few hours later, I got a call from people from Aring. Hey, we have ready the CD for you. I know that's important, but we need one last detail. Please, the registration number of your airplane. Shit. So, yeah, okay, you know I don't have it. I know you draw it, but let's make like nothing happen. So I said, yeah, well, actually, I don't know which airplane is going to be that. I have a bunch of them. So send me an email. I will send you the registration number as soon as I know which is going to be the airplane. Okay, so game over. That's how an aviation security research starts. Okay, with stuff like this. But you may be lucky. And then the day after, you go back to your to buy some bread, and you find on your mailbox the extremely urgent packet from Aring with your shiny new AMI disk. Hooray, thanks Aring. You get your packet, you go back to your place, you open it, you see the CD, and then, what the fuck is this shit? I mean, I ordered this CD, I wanted this CD, I needed the CD, but now then I realized, okay, I don't know what the fuck I asked for. So, but it's nice, I got it. Hooray, I win. So next step, obviously, is go to Google or your aviation documentation that you have been collecting and say, okay, what is an AMI? And then just realize that an AMI means airline modifiable information. Okay, and it's some data that the airliners are allowed to modify and then upload into the systems of their airplanes, because it looks like there are some functionalities that can be modified by the airline. Let's say that the airline has their own communication procedures to communicate with the pilot or from the pilot to the ground, and they need some specific communication detail. Instead of having to buy a specific or modify the hardware and everything to get that, what they got is this CD, they modify the information they need, they ship it to the airplane, they upload it to the airplane, and so the systems can be adapted into the needs of the airline. It's all about money, okay, it's great. But it is just one of the many things that work this way, okay. Looks like finally aviation industry came into the new century, and they invented the so-called software updates, okay. So they have the so-called loadable software parts, which are divided into different groups, and it's just these different configurations or code that you can either modify or just update easily without having to remove the hardware and put a new one. Believe it or not, that was the way it used to work until 5-10 years ago. You wanted to update the hardware of the airplane? Okay, no problem. Go to maintenance, disengage the cockpit, remove the black box, put a new one. Now you can do it with a software update like we've been all doing for many, many times. Okay, so there are the OPS, which is updates into the code of the running on the system. The OPC, which is the same but for configuration or databases, okay? And then you have the AMI, which is for airlines specific, okay? Okay, so I said, great, looks like I got a CD with some data software that I can upload into a system of an airplane. So obviously, if it's an OPS, you may think, oh, great, let's modify the code and create a backdoor. I'm more interested into vulnerabilities, so I was looking for AMI and OPC, and I was looking for data parsing vulnerabilities. So that I upload a modified AMI, and while the system is parsing this data, to try to crash, to find a vulnerability in the parsing and execute code. Okay, that's my preferred option. So I said, okay, look like it may work. So what's the attack vector? So I have this. How do what are the options to update this AMI into the airplane? Then I keep looking, and okay, 3.5-inch disks. Doesn't look like a really nice attack vector to me. I mean, did you ever try to go to the cockpit with a CD and say, hold on a minute, I'm just gonna do a quick update? Most probably they're gonna ask you, who the fuck are you, okay? So, another game over. But come on, it was nice. We didn't spend a single euro, we just filled up a form, went through some embarrassment with a phone call, but in the end it's not that difficult. All of us can do that, and searching Google is not that difficult also. But I don't like to get stuck on this. I mean, I saw potential on this attack vector, so I said, let's try to see. So I thought, okay, in order for that to work, okay, what do I need? oh, easy. I need to be able to load this remotely. So I went to Google and I say, okay, is there any way to load an AMI wirelessly remotely? And Google said, sure. What you're looking for is called Teledyne Technologies. Well, in the end, there were many names, okay, many companies, many products, but this is one of the most important ones. So I said, great. What does Teledyne Technologies has to offer me? So I went to their website and they told me, okay, we've got something called Teledyne Lodestar Server Enterprise. Eliminate the floppy disk and the CDs. Great. Web-based distribution instantly transfers software parts, what we already saw, to the data loaders, okay, directly to the airplane, wireless links. Sounds great. And this integrated solution makes it possible to electronically across the entire fleet with the single press of a button. That means one AMI, one exploit, one button, the entire fleet is mine. Like it, I like it. I also saw the picture and I say, yeah, I can be this guy sitting on the computer distributing all this data to the airplane just with a single click of a button. I mean, do they provide a keyboard with just one button and the letter distribute? Go, it's gonna be red. Okay, so I kept looking for that and say, okay, what do you understand by wireless links? That can be tricky. So I scrolled the website and they told me, no worries. Simultaneously, you can use 3G, 4G, cellular radios, or even if it's not good for you, wireless access point. It's average Wi-Fi technology. Hold on. So either the airplane lands, automatically connects to a wireless access point, and then start to receive the updates. Most probably airlines are not going to go for that because that would mean that they have to provide with a specific access points on each of the airports that they're flying to. So most probably they're going to go for the 3G, 4G connection. Last time I checked, that means that the airplane lands on the airplane, the system starts, deploys the antenna, connects the 3G, 4G, and they have a public IP address. And they start receiving the updates, requesting and receiving information. Is that possible that those people, those crazy people, just put a public IP address on every single airplane out there? And that this public IP address is directly connected to the avionics systems on board the airplane? The answer is yes. What can go wrong? I mean, it's perfect. I see that. Okay, great. So, awesome, but on the other hand, who is using that? I mean, if it's just going to be used by one small airline over wherever in the world, is not that such a big finding. Okay, so let's see who is using that. You keep looking for that. Okay, over 40 airlines worldwide, and every single modern airplane that you can think about, it's certified to use this technology. Right now, it's over 100 airlines, by the way. It's increased a little bit since my last research, okay? So looks like there are some targets here, okay? It's not just that you're going to be able to use that against one or two small airplanes. It's going to be at least 5. I don't know, a few of them. Okay, great. Now, but airplane is not the target. The target for us is the systems on board this airplane. What systems can we interact with by using these Teledyne technologies? Am I the only one that reminds of Terminator with these Teledyne technologies? Okay, so you keep digging into the brochures of the products and you say, okay, which systems can I update via this technology? That was. I mean, I had to rest after that because flight management system, integrated display system, aviation condition monitoring, the central management system, automatic flight system, autopilot, if you don't understand that, flight management computer system, and so on, so on, so on, so on. And among others, once I already had the systems I already had at my place, so I could even try that with the systems I had. So up to 100 airlines using that, every single airplane certified for that, and more than 12 systems that I can reach. You are asking for it. I mean, you are really asking for it. I gotta try this, okay? It's not that difficult, as you can see. Just some digging on the internet, filling some stupid form, and then like in 2 days or 1 day, you just came up with a new attack vector for airplanes. It's great, okay? So how does this new attack vector, this new attack looks like? Easy. You prepare your AMI with the vulnerability, the exploit inside, okay? You get into one of those systems, and you press this big red button, and it's going to be deployed to all the airplanes via standard technologies, 3G, 4G, Wi-Fi, okay? No need for ADSB, no need for ACAS, no need for nothing aviation specific, okay? The complexity reduced also for you, right? The requirements, all of you can do that. So either you go to this website that they have, okay? I cannot give you the details on the vulnerabilities, but it's a website, and spend 5 minutes. Okay, just your preferred browser, Barb, for example. It doesn't need to be the pro version, the free Barb, and spend 5 minutes browsing this web application. You may say, okay, how the fuck do I find this application? One word, Shodan. Okay, I'm gonna leave it here. And then 5 minutes. You may think, okay, but come on, this is a critical system. It's gonna be open to the internet. Great, sure. Or, as I said, every single airplane right now has an IP address, public IP address, or wireless connection. Either you go ahead 2 hours before your flight, your next flight to the airport, open up, once you're on the gate, open up your wireless, your laptop, you know how to do that, and start looking for some interesting wireless connections, hotspots, okay, and monitor a little bit the communication, or again, do you know how to discover IP addresses? Do you know how to know which services are those IP addresses running? Do you know how to get a banner? Okay, then you can find airplanes. That's all I'm gonna say. Don't be scared if at the beginning you don't understand how to talk with this protocol, or is that encrypted? Okay, we can call it encryption, but just try it for 5 minutes, okay? Don't get worried about that. Trust me, it's not that difficult, okay? But of course I cannot provide the details. Sorry, but they will never fix that for sure, but I have to wait, okay? So, the delivery, it's easy. We already know that it's right now used by over 100 operators around there, where you're gonna use Wi-Fi technologies. Do you see the yellow box over there? Is that an iPad? I see. Okay, I'm going to leave it here, but the only people using an iPad on a cockpit is the pilot. And right now you're also allowed to use, maybe next time that you are going to fly, try to get a front seat. And once you are on the air, accidentally engage the Wi-Fi of your device. I don't know. You may find something interesting, okay? But and you say, okay, great, that may work. I'm sorry, I know I'm not giving the details, but honestly, I can't. Okay, I mean, every airplane has a public IP address. Do you honestly would release the details of that? No, right? You understand me? Okay, I will release more details later, but I can't on this phase. So how do I find the targets? Who is actually using, which are those 100 operators? How can I know which airline is using that? Really hard work of asking Google. Or just go to the Teledyne website. They are proud. Every single time an airline is using their products, they put a press release there. So you will see Norwegian, I know that one, NAS, TUI Airlines, Gulf Air, AirAsia, KLM, it's a small company, right? And so on, so on, so on. So you got the names. You know which company you have to look for, okay? If you got the name of a company, are you able to know which IP address range do they have? Right, you know how to do that, okay? I'm just gonna leave it here. Okay, so come on, it's there. It's just go ahead, go for it, no problem. But don't mention my name, okay? Great. Now, okay, we know how to deliver that. And we know how to get the code that is going to be uploaded into the systems. And we know how to modify that code to try to find a vulnerability. I think this guy over there is going to talk about parsing vulnerabilities tomorrow at some point, right? Great. So I will leave that for you, okay? If you want some aviation system to do some demo, it's okay. I can give it to you. But it's going to be on your... Come on, that's funny. So I got all that, but now I have to find the vulnerability. I have to find to code the exploit, to try everything. I mean, it's not just that I can do this test directly on an airplane, right? Well, I can do that, but it's not going to be, I mean, use your common sense, right? So I need the code. Somehow I need one of those systems or the code running on those systems, okay, in order to be able to say, okay, if this code is going to be using this data, and I modify this data, is it going to work or not? Do a static analysis, dynamic analysis, fuzzing, manual testing, whatever you want, your preferred option, but you need the code. How? Okay, great. Either you go shopping. From my experience, even if you have the money, they are not going to sell it to you. They're going to ask, okay, do you have an airplane? Do you have an airline? Do you have something? No, okay. And they're going to stop answering your emails. Or you can use Google and to look for airline websites. You use that on Shodan, and you see which subdomains and other servers are out there. My 2 cents go for the 80 TCP port, so web servers, okay? You should look for the domains and websites that look like it's being used by the people of the maintenance of the airline, you know, these people that go and fix the stuff, because those are the ones that are updating and taking care of the systems. And you may even find, for example, that some South America big company has a website with directory listing enabled, and every single document, program, data, firmware, and everything classified with directory listing, folders, files, and everything. Because come on, you're one of those guys, you have to go to this airplane and, I don't know, get this code and update. You're not going to waste your time with username, password. Just go to the server, download what you need, or read the document you need, and that's okay. If it happens to be open on the internet, it's because it's needed, okay? So, my 2 cents. That's one nice way of getting the code, okay? And then you have a firmware update. Come on, how many of you on the last 6 months, 1 year, got a firmware update of a router or something and just run it through a file command, decompress, bin walk? Looks like a binware binary. Let's open that with IDA or Radare. It's not that different from our everyday work, right? To take a look to a firmware update. Okay, that's all. And you have the code of some of the... Okay, you may not be able to say, I need this specific model, but honestly, come on. At least you will have a few of them. In the end, it's just about finding some vulnerabilities and trying to guess if the attack vector is real or not. So I happened to find also this, okay? What I had was, in the beginning, for my first talk, I got this training software that was, in the end, the real code of the real system of the airplane. It was, in the end, a memory dump and some Visual Basic user interface for Windows, so pilots would be able to use that for training. It's a complex system, so before going to the airplane, they install that on their laptops, they train a little bit, they know how to use the system, and then we all feel safer when we go into the airplane, okay? But the source code, the code of this training software was exactly the same as the real system, okay? It's just that one of them was running on Windows, the other one is running, let's say, on a real-time operating system like VxWorks, okay? But it's the same code. So why do I go through that? Because I got this firmware update, I could go through it, static analysis, looking for vulnerabilities. It's okay, but at some point you're going to want to be able to run this code. Okay, if not, you're going to find potential vulnerabilities, but it's not easy to develop an exploit without being able to run it, okay? So what I did was I got this training software that I got by $20 on a game shop in Ohio via eBay, okay? And I said, okay, source code is the same, it's just compiled for Windows. So we have the flight management system code running on Windows, but in order for this to be able to run, somehow it has to emulate other systems. that are present on board the airplane, but they are not present on your average Windows machine. So most probably they emulated that somehow, okay? So I just use my preferred reverse engineering tools, and I took a look on how do they created those fake systems so that the flight management system can run even outside of a real airplane, okay? And then I said, okay, now I have the real code, okay, running on VxWorks. That is not that difficult to get a VxWorks nowadays, okay? But in order to be able to make it run inside this VxWorks, among other things, I'm going to need also those fake systems. Now I know which are those systems and how do they work. I just need to code them a little bit, see, and feed some dummy values. Okay, I don't really need for the airplane flying, doing complex maneuvers. Even sitting on the ground, it's okay. But those systems have to exist and have to send them some values. Okay, so that takes time. It's not easy, but can be done. Okay, mainly because the training software is Windows, and it's coded in C, C++, Visual C++. So we are all used to do that. And if not, it's not that difficult. Okay. Just to get an idea of how it works, okay? Now, I was able to run the code, modify the AMI, supply that to the flight management system or whatever system, okay? It was parsing and loading, perfect. Now I start to modify that, find vulnerabilities, either fuzzing, manual testing, static analysis, you name it, okay? If you prefer. It's not about finding all the vulnerabilities, just one or two to be able to keep moving with the research, okay? But that's where it gets a little bit tricky for the exploitation. Okay, it's not anymore an average Windows Linux machine. We are talking about real-time operating systems. In this case, the VxWorks. Good news. Most probably, you're going to get the code for older versions of the system. They are going to be running older versions of the real-time operating system. Okay, it's easy to get up and running. So a little bit of information, okay, about this VxWorks by Wind River. Now it's Intel. It's all those nice features, okay, that say we are the best. Realize about this POSIX certified. That's interesting because we are all used to exploit systems that run on POSIX environments. Okay, so if it's POSIX certified, that means that it's going to be easier for us to program or use those APIs. Okay. But if you take a close look to this, you will see that this, in the end, talking about safety. This VxWorks is perfectly set up. So if the system, the process fails, it's going to restart, or it's going to disengage, or whatever, it's not going to make the airplane crash. But it's not talking about security. Okay? If you go for security on VxWorks, okay, for example, with this presentation from HD Moore, you will see that security is not exactly one of the strengths of this platform, okay? In the end, if you try to exploit something on an older or even modern real-time operating system running on avionics systems, you will realize that it's like going back to the 80s, okay? Think about any modern security feature, okay? It's not going to be there, neither. Stack randomization, prevention of execution, whatever, is not going to be there. You overflow the stack pointer, the program counter, you redirect the flow, you inject your payload, NOPS-led execution. That's all. POSIX certified, so you don't really need to know all the tricky programming on the, well, you have to know, but not that much in order to be able to play with that, okay? Let's see one short demo on this, okay? Yep, again, demo 2. Okay, where is it? Oh, shit. Stop. Here. Okay, let's go through it. If I do this, well, perfect. Okay, these are the contents of the AMI disk I got. A full disk with just these two, well, file and folder, okay? And you can see below, we will go through it later, the VxWorks environment, okay? So let's take a look to this file, okay? First of all, we take a look at the file, and it says is the update, and the directory you have to take a look is this one. And then check for this other file. Great. We go to the file, the folder. We take a look to this file again, okay? And it's going to tell you, okay, the file you are looking for is this one, which is the actual database update. Kind of stupid, but come on, it's okay. We found the real database that we want to take a look for too. And then we take a look to this file, which is a little bit bigger, okay? So let's go to the less, and we check, and you will see that it's, I don't know, commands and things. Specifically, this AMI is for the keyboard and, well, the flight management system keyboard and screen that the pilots used in order to interact and program the flight management system. Okay, this one is used to program the screens. Okay, it's like it has different screens with many options, like a big menu. Okay, with this you can modify this. You can add new menus, new entries, modify or remove. Okay, so what you're here seeing is that. Okay, you see that uplink over there. I don't know, and okay, that's all. Then we can go here, and I have 3 different versions of the program. The original one, proof of concept of a crash, and the exploit, okay? Great. I'm not going to show the exploit, but if you are a little bit clever, okay, it's going to be more than enough. Okay, let's take a look to the crash, I think, yeah. So we go to some specific part of the file, mainly the Japan, okay, over there on the top, and you will see that I just added a bunch of A characters to the end of Japan. I made it by hand. I didn't use any fuzzing technique, okay? Okay. Now, let's go second chance. Now, this is the development environment for VxWorks, and it happens to have an emulator to run the VxWorks operating system. Great, no problem. And so I have here some projects, and here you have the environment, okay? Here's where we are going to run the code that I got for the flight management system. You can see here that we have avionic files and these avionic simulator files, which is all the files that I had to code in order to fake those systems, okay? These are the fake systems, okay? That's a bunch of them, okay? Wings, flaps, blah, 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 radio, avionics, no problem. And then this is a VxWorks 5.5.1, older, because as I said, usually the airplanes use a lot of legacy systems, so they run on older code, okay? So let's start the flight management system with those emulated systems, okay? We feed the AMI file, the original one, okay? And print some output on it's parsing some fields, in this case, it's areas, okay? Great, everything went fine, okay? Now we're gonna do the same, but instead of feeding it with the original file, we're going to use that with the proof of concept of the crash, okay? So we start the flight management system with the crash. This is just to make it easier, okay? Just to start easier. We provide different proof of concept, different database. We go to Japan. Oh, something went wrong. Access violation, program counter. We all know what's that. 000020. Great. Let's take a look to the file and see what happened here, okay? So we go to Japan, and we realize that after the A's, there is 00002020. You know the NDNS, okay? You have to switch it. So it looks like this is going to be the offset, the address of the next executed instruction. So I don't know. You all know how this works, right? So I didn't provide the exploit. You see that there is no exploit here, okay? If you happen to be able, because if you are really smart guys, very skilled, talented, and after years and years of hard work, you are able to use this information to develop an exploit, it's up to you, but I didn't provide you with the exploit, okay? So, as this is an old video, because I don't have everything here, we're going to right now start the flight management system, but with the exploit, okay? As I said, welcome to the 80s. No security problem, no stuff protecting you, preventing you to run code, okay? Forgive me, as I said, this is an old video because of what happened with my company and the hardware, so this is a demo for other talk, but it's easy. POSIX compliant, so it's not that difficult to just print something on the screen. And we prove that the vulnerability exists and you can exploit that, okay? Easy. Okay, that was this small demo. Now I should be able to close this and then come back here, go to the demo, new, after all this, here. Shit. I think I broke the slides. Okay, fixed that. Or no. Okay. Demo time. Yeah, great. So that was the demo on how to exploit, how to find the vulnerability and exploit the avionics system, in this case the flight management system, using one of those AMI. It's not that difficult, and in order to be able to run that, this old legacy Tornado development environment is available on the internet because it's so old nobody cares. Okay, it's for Windows. You install that, you can code or run the code. Okay, a little bit of code is required and some reverse engineering in order to be able to run this firmware on this environment, but it's possible, it's feasible. No really big problem here. Okay. So almost to finish, I'm going to talk about the project Catenstein. Okay. Which happened to be a dead project because this project relies on some hardware that I lost. Okay, it was mainly a brain transplant. Okay, and it was in the end this. It was a drone, a laptop, some antennas, and some stuff that we will now see. Okay, what's the purpose of the project Catenstein? Okay, the main problem I had is I cannot have an airplane. My previous company didn't buy me an airplane. They said it was too expensive. I didn't saw that the same way, but it was not my money. But in order to prove that on a real environment, you need an airplane. Good news. I lost my hardware, but now I have some friends that are providing me with access to an airplane. Real airplanes, by the way, with all the systems, very modern systems, by the way. So even though I cannot show it here, I can tell you in advance that all this research works smoothly on a real airplane, by the way. Most probably on my upcoming talk in another conference, I will be able to provide some videos or demos, but okay. By that moment, I couldn't have an airplane, okay? In the end, an airplane, from my point of view, is a bunch of sensors in a big box called airplane, a flight management system that was using the data of these sensors in order to tell an autopilot what to do. In the end, that's everything of an airplane for me. So I said, okay, I can't have an airplane, but maybe I can have a small drone. In the end, a drone is the same. Engines, sensors, autopilot, okay, manual control, automatic control. So what if I put a flight management system in between? What if I can manage a drone using real airplanes avionics system, in this case a flight management system? That can be awesome. Okay, so let's do a brain transplant. We are going to take the brain of an airliner and we're going to put that on a small drone. As you can imagine, the brain of an airliner is like big and the drone is like small, so you have to do some tricks there, but it works. In the end, it's just easy. You got the drone flying in autopilot or manual, okay, like any airliner. You may take off manually, then you engage the autopilot, and it's going to fly automatically like any airliner, okay? Just that. Instead of telling you what to do to the autopilot, okay, let's use the real flight management system of a real avionics system. It takes some work, okay, because if you imagine an airliner and a drone like this one, you can see that there are some differences, okay? So some work has to be done, but it may work, okay? And then you have suddenly something that is flying with these systems, and that if you exploit and goes fine, maybe you will be able to see how it goes, and if you exploit and it fails, you will also be able to see how it goes, what is really happening, because it's not code on a laptop isolated anymore. It's interacting with many other systems, sensors, actuators, engines, and it's flying. So that was Project Catenstein. Okay. Now I am going to show you a demo. The drone is no longer with me, so it's not here for your pleasure, although most probably it's too dangerous also to make a real demo here. But I have the video. I'm going to show you the video and some nice pictures and everything, okay? And almost finished, by the way. So this is a picture of the place where I made the tests. I live here, Berlin Tempelhof, really near. It's a coincidence that I live near an abandoned airport, honestly. this is the drone, okay? It's not that small, not that big also. It's a nice drone, okay? That it's able to fly and fly high, okay? That's great. So let's say connecting the brain of an airliner into a drone doesn't always go as expected, okay? So sometimes you just tell it, hey, land. And it says, okay, I'm going to land. And then you spend most of the evening collecting the spare parts because it crashed, okay? Sometimes, after some hard work, you say, okay, 100 times later, engage this flight management system and say, please land. This woman didn't care about the drone, no problem. And, okay, a little bit hard, but it landed properly, right? Okay, now I'm going to show you the exploit working, and then I'm going to show you the exploit not working, because it works one of each 10 or 100 times, okay? But no drone was killed during the preparation of these videos, okay? Fine, let's go for the demo 3. First, what's that? No, stop. Hey, stop. Where is the mouse? Here. Woo. Okay. Hold on a second. Now, where is it? Here. Okay, move it over here. Double click, should work. Perfect. What are we seeing here is 3 different panels. We will see the third later, okay? On the left, it's what the drone is actually doing, okay? We got some telemetry data, okay? So that's the point of view of the airplane. Right now it's steady, quiet, like on the video, okay? Doing absolutely nothing. Here, this is the flight management system of the real airplane, okay? That is connected to the drone and is telling every time, do that, do that, do that, okay? Not yet. Okay, is not engaged. And on the right, we will see the hacker doing the application, okay, the attacking. Okay, so first we start the flight management system CAT of Catenstein, okay, which is going to do is connect the real flight management system with the drone via telemetry link, okay. So it's starting. Everything okay. This is the Android application that I presented, blah, blah, blah. Yeah, everybody was complaining about the Android application, but it's really nice for the demo, okay? We're going to use that to exploit or attack the drone. So everything is started. We are going to connect to this airplane, okay? I call it Entrance 1 because that was the name of my former employee. Did I mention I'm unemployed? Good. So we're going to select this virtual airplane, okay, the Entrance 1, and we're going to go for exploit, okay? So we are sending the exploit. Okay, white, exploited. In the end, target successfully exploited means that we sent a AMI file. You can see on the middle that loading a new AMI file, okay, it's going to be parsing it. Okay, you already know that. It's going to go to Japan. It's going to wait a little bit. And it's going to say, Simon says, here I am waiting for commands. Okay, this is the name of this kind of payload that I use for aviation. So it takes a while to upload it via telemetry link, although it's a tiny one, okay? So right now, the device is flying, the flight management computer is controlling it, but we have this payload running on the flight management system waiting for our commands, okay? So the plane is still flying and everything goes okay. You can imagine the drone flying at 4 meters, okay, and there. So we select the payloads. We select apply new flight plan payload, okay? It's the easiest one, just upload a new flight plan, and tell the flight management system, forget about everything, apply this flight plan, and don't tell the pilot, okay? So we're gonna apply this new flight plan, okay? And it's gonna take some time, upload it, and okay, Simon says, applying new flight plan, you see that, and it stops to listen. The drone starts to move, okay, you see that on the left, it's the autopilot moving, the new flight plan, and on this application, using this information from the pilot, from Simon, we can see on this map, with some difference in time, that the drone is actually, so you can monitor the target once you exploited it, okay, on this map. You see, it's Tempelhof Airport, where I used to fly with it. So, this is what happens when you exploit this Catenstein, okay, and everything goes fine. It's possible. It flies, it keeps flying, and you can tell it to do whatever you want, okay? not that much, not that bad, but sometimes, oops, sorry. Sometimes you just tell it, okay, let's apply the exploit. And now, apply, exploit, wow, okay. And then everything goes fine and goes wrong, the flight management system crashes, the airplane doesn't know what to do, so it starts to fall. Good news. On most of the situations, the only thing you have to do is disengage the autopilot, go back to flight manually, like any other pilot, okay, apply power, and nobody dies, okay? So, but as you can see, most of the times that's what happens, okay? The airplane crashes. Not nice. Okay, so it was here and here. So that's the actual status of my research. Okay, maybe the drone is a little bit too expensive for most of us, well, at least for me right now. But aside from the drone, it's not that difficult to just recall we were visiting some internet websites looking for funny cat pictures, and 1 week later we are executing code on an avionics system, on a VxWorks on our computer. It's not that difficult, and as you can see, there is nothing that much specific for aviation, no high requirement, no nothing that prevents any of you of doing that, okay? So that was all.
So, thank you very much, Hugo. So after seeing you crash stuff like that, are you sure? Did you show that video about the drone crashing to the guys that are lending you an airplane?
Which video? No, but of course we are not doing any kind of test with the airplane on the air. It's everything on the ground, so no real danger, and it's just to. In the end, we are not trying the post-exploitation abilities. It's just to prove that the exploitation is working. So we are not, of course, doing this with the real airplane.
But you have an airplane to try on.
I don't really have it. It's not under my name. But sometimes if I ask, they say, yeah, sure, come in and do some stuff and don't break anything. So yeah.
Wow.
That's great.
What's the reaction been from the vendors since last year?
Oh, the same. It's just me. As long as I don't really have a real airplane, an airliner flying on a real flight, and I applied my research, they're going to deny everything. And as FX said, it's cheaper to deny or lie instead of apply anything. So that's the reason. If next year or in 5 years there is 20 persons with different attacks on different systems, different procedures, different something on aviation, that may change. Right now, nothing's going to change. There is no need for that. If
somebody's looking for a project, this seems like there's a lot of research done. It's not really that difficult to get into it.
Next month at T2, okay, there's going to be another talk, maybe the last one on aviation security. I will go deeper with more details. I don't care if you are not going; it's no problem. I'm going to release as much details, tools, and information as possible to make for the people easier to engage into this kind of research. So if you just follow me on Twitter or check my website from time to time, by the end of October, beginning of November, a lot of new material will be published and tools, and you will see. It's going to be fun. So that was just an introduction to get you a little bit curious on that. Hopefully.
Awesome. We're actually a little bit over time. And since we're going to do the lightning talks, I'm going to thank Hugo very much.